Good afternoon. It is Sunday. It is 2 o'clock. It is November 24th. You have homework. You might not know how to do it. Let me show you. Here I am on Google Classroom. If I scroll down just a bit, I can see here are the things that Mr. Bauman told me I need to have done by the end of the day. Friday, November 22nd. Again, it's November 24th. Here's how to do those things. First, number one, index fossil stuff. You see right here. If you didn't do the Pear Deck, you should do that. All you gotta do, pop this link right here. Check it out. Oh, I need to sign in. This is going to be good. Okay. Yeah, how am I feeling? Let's say I'm feeling happy. Happy's good. Ooh, can't wait to begin my journey. Okay, here we are. Which index fossil is best? What slide is this? 15. Remember how many slides I told you to do? If you go back to the directions, it says you need slides 8 through 14. Technically, it's 7 through 15, but hey, you know what? Who's counting? Am I right? Okay, so this is the first slide you'll actually need. This is the first one where we write answers. There should be an answer sheet that you make that has this, the answer to this question on it, which you will answer based on the information that you know about index fossils, which you could get from the 7 slides before it if you look. So, kicking through these slides, you're going to figure out what the best index fossil is. This is an example. It tells you which one. It's this one, the spirally shell, also called a gastropod, because, most importantly, it's limited in geologic time. If you don't know what that is, that's tough. Then you enter these ones. This is the last one. And then you're done. Hooray, great job. Okay, Pear Deck done. Write the answers, go on. Number 2, you can't do this one unless you're in my classroom because the materials are physical and they're in the classroom, so sorry. Next one, it says attached to PDF for the correlation lab. It's actually not right here, but it's down here. This is what everyone's been asking me about. How the heck do I do this lab? Here we go. Correlation lab. Cross-section number 1 and number 2. What do? I put the layers in order. How do I do that? Using the laws of relative dating. What am I calling my layers? There's no letters. There's no numbers. Okay, good. Here are the names of all those rock types. So on the bottom here is something called a conglomerate. It's a type of sedimentary rock made up of different types of, or different sizes of particles. You might notice here that there's 1, 2, 3, 4 layers. Well, there's also a fault, 5, and there's also an unconformity, 6 things to write about. How do you know how many things should go on the answer sheet? Well, if you scroll down to the answer sheet, you shall see it. Look at that. Cross-section number 1. Cross-section number 2, oldest, youngest. It tells you exactly what to do. Procedure B. That's for cross-section number 3, which we're going to look at. You'll see it has 1, 2, 3, 4, 5, 6, 7, 8 rock layers. Here's how you do it. Okay, so cross-section 3. Here's where the party begins. If you look at the bottom of each of these columns, you'll see there's 1, 2, it's here and B and here and D, and 3 different types of rock on the bottom. One of those types of rock is the oldest rock. Which one is it? We have to figure it out. So what we're doing is making one stack of all these rock types. So vertical wavy lines, it's here. It's at the bottom here. But it's also here. It's not at the bottom here. Therefore, vertical wavy lines is not the oldest because there's something under it. It's right here. Horizontal wavy lines. See that? It's here on the bottom. It's here on the bottom. It's looking good. Except it's also here where it's not on the bottom. What's underneath it? V's. So V's, which I believe is basalt, that's going to be your base layer. Then, next one up, horizontal wavy lines. Then, next one up, vertical wavy lines. What's above it? Well, this conglomerate's above it, and it's above it in 2 of the 3 places, and you'll notice that the plus signs are also above the conglomerate. So, it must be the conglomerate. You can figure it out from there. I think I'm just giving you half of the answers, so that's good enough. Let's go on. Cross-section number 4. This is where the fun begins. Down here, you'll see the pectin is from the Paleogene, the crinoid from the Mississippian, etc. I have given you the length of time that these time periods happened on Google Classroom. I want you to go and look. You'll notice that the Devonian is the oldest time period that's listed here, which means the trilobite's the oldest fossil, which means any layer that the trilobite is in, or that's under the trilobite, must be older than all the other layers. So, layer number 1 is this one that's a double layer, sandstone and conglomerate. That's the oldest layer. Then, this guy, limestone. Then, the shale layer that our trilobite is found in. Okay? So going up from there, you'll notice the plus signs and the sandstone that has the crinoid in it are in the same order as these plus signs here and these sandstone layers here. These 2 layers are actually the same. So you should have 1, 2, 3. This is 4, 5. This is also 4, 5. And then you can make the connection. Ammonite and ammonite. Look, they're even in shale together. Wow. This is the next layer. 6, and then 7, and then 8. What goes on top of 8? See how this is different? It has dots and lines. This just has dots. So the pectin's actually in 2 layers. This layer of sandstone and this layer of, I forget what it's called, sorry. Slap that on top. And then on top is another layer of conglomerate. Hooray! That's literally the entire answer. That's how you do procedure part 4. Why do I want you to do this? This is really important stuff to see
How do we take rock layers from different parts of, let's say, a state like this one? These are from all across New York, and try and sequence them to correlate them, to put them in order. That's what we're doing here.